Okay, grade 8, welcome to your tutorial video on how to use integer chips to model multiplication. So in the first chapter of 8.1, it says determine each product using integer chips. Use diagrams to show your thinking. So when we are using integer chips, we want to think about the idea that this integer chip is going to represent +1 and an open integer chip is going to use a -1. Now in the book they use colors, but since we're not using the textbook, we're going to use this as our kind of our key for how to use our integer chip. So if we think about this first one, what does it say and what does it mean? Well, back in grade 4, you learned that if you had 3 times 2, this meant 3 groups of 2. And you learned that it was one group of 2 plus another group of 2 plus another group of 2. And you learned that was 6, and therefore this was also 6. So multiplying was really the simpler way to do repeated addition. When we're dealing with integers, positive and negative whole numbers, the same idea of repeated addition holds true, except for, in this particular one, we're going to read it as or interpret it as adding 4 groups. So adding 4 groups is what that +4 integer means. 4 groups, excuse me. And the multiplication symbol is going to be representing the word of. So we have adding 4 groups of +2. So if we thought about that as from a grade 4 perspective, it would be one group of +2 plus another group of +2 plus another group of +2 plus another group of +2. Or if we were to draw it using this idea up here, we would have one group of +2, and we're going to circle it to show that it's a group, and we're going to add it. And then we're going to have 4 of those. So I'm going to use my cheat button here. Include 2 groups of +2, 3 groups of +2, and 4 groups of +2. Adding 4 groups of +2, we can see from the picture, is clearly a +8. If we use it in repeated addition, we see it as being +8. And if I was just to interpret it, it should be +8 as well. So all 3 methods, words, repeated addition, and modeling, give us the answer, +8. Now if we look at the second example, B, B says +5 times -2. So if I interpret this, I'm going to think of it as adding, that's what the positive symbol can kind of interpret as, adding 5 groups of -2. So in word form, this expression would be adding 5 groups of -2, or 1 group of -2, 2 groups of -2, 3 groups of -2, 4 groups of -2, and 5 groups of -2. So if we think of it from this perspective, I know my answer is going to be, hang on, let me just slide this over here. My answer is going to be -10. Now if I think about it as modeling, there's one group of -2, and I'm going to add it this way. I'm going to then clone this 5 times. There's adding 2 groups of -2, 3 groups of -2, 4 groups of -2, 5 groups of -2. And when I count the integer chips there, I'm going to have -10. So again, interpreting it in word form, interpreting it in repeated addition, and interpreting it in modeled form. Now the third show you know, where it says -4 times +2, this negative symbol in our first integer is not going to be adding 4 groups, it's going to be removing 4 groups of, right, our multiplication symbol is of, +2. So removing 4 groups of +2. Now the difficulty becomes you can't really express removing 4 groups of +2 in terms of repeated addition, because repeated addition, that idea from grade 4 was this number plus this number plus this number. But if we're removing 4 groups, you can't model it with repeated addition, but you can model it with integer chips. So what I'm going to start with here, like I did in all my other pictures, I'm going to start with this idea of a 0 pair. This here has a value of nothing. So if I was to take this and infinite clone it, and I was to make 8 of them, okay, that is still has a value of nothing. But if I think about removing value from something, removing 4 groups of +2, if I remove positivity from something, I am making it more negative. So yes, removing positivity creates more negative. If you remove positive or warm water from something, the water will become colder. If you remove positive values from your bank account, meaning taking out money, your bank account value will become lower. So this idea of removing groups of positivity from something will make something more negative. So if I think about circling a group of positive 2, there is one group of positive 2. And if I remove it, I'm going to put an arrow here to show that I'm removing that group, removing another group of positive 2, removing another group of positive 2, and removing another group of positive 2. So I knew I needed 8 because 4 times 2 is 8. So I started with 8 zero pairs. And when I removed those 4 groups, if you wanted to, you could actually physically erase them if you wanted to. Oops, I can't erase that one, can we? Take this one and remove that part. So if I remove those 4 groups of positive 2, I can see that my answer is negative 8. So I'm just going to bring that back. So when I move 8 groups of positive 2, my answer is negative 8 from a modeling perspective. Okay. The hard part is you have to start with nothing, but the nothing of removing groups has to be a nothing made up of 0 pairs or a nothing made up of something. All right. If I think of the second example, so the fourth example, or the fourth example here is negative 6 times positive 1, which is going to be, again, this symbol here is going to be read as removing, right? We're not adding like we were in these two here. We're going to removing 6 groups of course, multiplication is of negative 1. So we're going to remove 6 groups of negative 1 with this particular one. It says we're removing groups, not adding groups. We're going to start with 0 pairs, right? Enough to make 6 groups of negative 1, which is going to be 6 0 pairs. So we'll infinite clone this. There's 0, 0, 0, 0, 0, and 0. That's still nothing. And if I remove negativity from something, it's going to make it positive. So that's the same thing as thinking if I remove cold air from a room, it's going to make it warmer. If I remove debt from my bank account, I become richer. So removing 6 groups of negative 1. There's 1 group, there's 2 groups, there's 3 groups, there's 4 groups, there's 5 groups. Removing 6 groups of negative 1 gives us an overall value of positive 6, right? It increases something by a positive 6. Removing negativity, or 6 groups of negative 1, has a positive 6 effect on whatever it is you're removing it from. And finally, in this same idea, modeling with context, it says for 4 hours, the temperature in Victoria fell by 2 degrees each hour. What was the total change in temperature? So hour 1, it fell by 2 degrees. In hour 2, it fell by 2 degrees more. Hour 3, it fell by 2 degrees more. And finally, the 4th hour, hour 4, it fell by 2 more degrees. So as we can see, these hours are really groups, right? They are 4 groups. And each one of those groups is minus 2, so it's 4 groups of negative 2. So 4 groups is a positive 4 of negative 2. So our expression that represents this context is positive 4 times negative 2. And if I think about that, or think of it in repeated addition, falling 2 degrees, falling 2 degrees, falling 2 degrees, and falling 2 degrees, or negative 2, adding a group of negative 2, and then if I took that and cloned it, oh, I can't do it again. Adding another group of negative 2, adding another group of negative 2, or adding another group of negative 2. No matter how you look at it, the overall temperature change is therefore negative 8 degrees. So therefore, we're going to, because it's a story problem, the change in temperature was negative 8 degrees.